Hello everyone. Now we'll solve few gamma functions. For example, we'll try to solve a problem something of the form integral 0 to infinity x e raised to minus x square into dx integral 0 to infinity e raised to minus x raised to 4 upon root x into dx. Now, if I want to evaluate this integral, I have two single integrals 0 to infinity x e raised to minus x square, 0 to infinity e raised to minus x raised to 4 upon under root x. Now, I am only interested in the exponential terms which I have. The two exponential terms which I have is e raised to minus x square, the first integral which I'll name it as I1, and the second one which I'll name it as I2. In my I1, I'll be interested in the exponential term. So the I1 ka value, let I1 equal to integral 0 to infinity e raised to minus x square into dx. In this wala part mein, and the other one is x. Now here I have e raised to minus x square. Into this e raised to minus x square, the coefficient of my exponential term raised to something, that something ka coefficient should be minus 1 and the power should be 1. Now the coefficient is minus 1, no problem, but the power is not 1, so we'll make a substitution. Let x square equal to t. X का value will be t raised to half, dx का value will be half t raised to minus 1 by 2 into dt. Similarly, in my I2 wala term में, it will be let I2 integral from 0 to infinity e raised to minus x raised to 4 upon root x into dx. The next, in this wala case में, I am interested in the exponential term. In the exponential term raised to something, that something ka power should be 1 and the coefficient should be minus 1. Your coefficient is minus 1 but the power is not 1, so I'll write down that x raised to 4 equal to t. This will be, now instead of t has been already used, so I'll write down it to be some u. And this will become u raised to 1 by 4, dx will be 1 by 4, u raised to 1 by 4 minus 1, which will be minus 3 by 4 into du. Now the limits of t integral is 0 to infinity. When x is 0, t is 0. When x is infinity, t is infinity. Similarly over here, I'll be interested in the limits of u. When x is 0, u is 0. When x is infinity, u is infinity. Now my integral 1, I1 and I2 turns out to be of the manner integral 0 to infinity, x ka value is t raised to half, e raised to minus t, dx ka value here turns out to be half, t raised to minus half into dt, into my I2 ka value will be 0 to 2, e raised to minus u, dx ka value here turns out to be 1 by 4, u raised to minus 3 by 4 into du. Remember, there is a root x in the denominator. This root x can be written as x ka value root u raised to 1 by 4. This turns out to be integral 0 to infinity. Half is a constant. Outside, e raised to minus t as it is. T raised to half and t raised to minus half gives me t raised to 0, which is, I'll write down here, into 1 by 4 outside e raised integral 0 to infinity e raised to minus u. This under root of u raised to 1 by 4 gives me 1 by 2. 1 by 2 into 1 by 4 gives me u raised to 1 by 8, which when comes in the numerator becomes u raised to minus 1 by 8, u raised to minus 3 by 4 into du. As per the formula of gamma function e raised to minus t raised to 0 dt into 1 by 4 0 to infinity e raised to minus u, this will be u du, minus 1 by 8 minus 3 by 4, minus 1 by 8 and minus 3 by 4 gives me, do the calculation, minus 1 by 8 minus 3 by 4 minus common multiplied by 2 8, this gives me minus 7 by 8. 1 by 4 1 by 2 here gives me 1 by 2 and 1 by 4 here gives me 1 by 8. Here using the formula gives me gamma 0 plus 1. This gives me a formula gamma minus 7 by 8 plus 1. We are using the formula integral 0 to infinity e raised to minus x raised to n into dx gives me gamma n plus 1. So here t raised to 0 gives me 0 plus 1. The minus 7 by 8 plus 1. So the final answer turns out to be 1 by 8 gamma 1. Minus 7 by 8 plus 1 gives me 1 by 8. So the answer turns out to be 1 by 8 gamma 1 by 8. Remember, gamma 1 is 1.